All right, so the first problem here says, what is the wavelength of radiation whose frequency is 1.5 times 10 to the 13th hertz? All right, so we have to use our equations here. We have C equals wavelength times frequency, and we have an energy equation. Energy equals Planck's constant times frequency. Hopefully this is coming back to you now from last week. All right, so what we're solving for here is wavelength, our little lambda, okay? So let's see, based on this equation, do we know C?
Yes.
Yes, it's a constant. We do not know wavelength, of course, that's what we're solving for. Do we know frequency? Yes, it is given. So for this problem, we only need to use one formula, plug in to solve for our wavelength. Okay, so we can do that. We know C is 2.998 times 10 to the 8th meters per second. We do not know wavelength, that's what we're solving for. Can we plug that frequency right there directly into the problem? Yes, it's in hertz. Those are the units we need for frequency, so we can plug it in. Okay, how are we going to solve for wavelength now? Divide, very good. How many sig figs do we need in our answer? 3. So we have to round it to 0.00 in order to get the 3 significant figures times 10 to the negative 5th. What are our units here? Meters. It didn't tell us to change to any other units, so we'll just leave it there at meters. Any questions on that one? Okay, the next one says, a certain electromagnetic wave has a wavelength of 5.5 times 10 to the negative 2 micrometers. What is the energy of the wave? All right, so we know we're solving for energy. Okay, so this is what we're solving for. Do we know H?
Yeah, it's a constant.
Yes, very good, it's a constant. Do we know frequency? No. So we can't start here, right? There's 2 unknowns. So we'll have to use our speed of light formula because we know C, we know our wavelength, so therefore we can solve for frequency and plug it into the energy equation. Is everyone good setting up these steps and understand where to go for this problem? Okay, so we're going to start with our speed of light. C is 2.998 times 10 to the 8th. Very good. We do have to convert it. You're exactly right. So now I want to plug in my wavelength. But this wavelength is in micrometers. Can I plug micrometers directly in? No. So Ken's exactly right. We've got to convert it first. So over to the side, we'll say 5.50 times 10 to the negative 2nd micrometer. If we have micrometers on top, we need to put micrometers on the bottom. Then we can go to a meter on the top. What's our bigger unit here? Meter. So we put a 1 with our meter. How many micrometers are in a meter? 1 times 10 to the 6th. So when we divide, we get 5.50 times 10 to the negative 8th meter. Now can we plug that wavelength in? We can. So we plug that in here. 5.50 times 10 to the negative 8 meter. We do not know our frequency. That's what we're solving for. So in order to solve for frequency, we will divide by our wavelength. And for frequency, we get 5.45 times 10 to the 15th. What are our units for frequency? Hertz. But we're not done, right? We want to find energy. But we have frequency, so now we can plug frequency into our energy equation. So we have E equals Planck's constant times frequency. We know Planck's constant, 6.626 times 10 to the negative 34 joule times second. And we know our frequency because we just solved for it, 5.45 times 10 to the 15th hertz. So now to solve for frequency, we will just solve for energy. We will multiply H times frequency, and we should get, how many 6/8 should we have? 3. So 3.61 times 10 to the negative 18th. What are our units for